mux. So the analog mux can choose between any of these 8 inputs and then apply it to the input. All this stuff right here is the A to D converter. So what the switch can be done, you can move it up to right here and it's going to sample this input, or you move the switch to right here and it's going to sample that input. So you have 2 different wires attached to each one, and that's the thing I'm talking about where it's switching between the 2.
Okay, so we have 2 circuits and then both of them connected to like a pin on the
That's
mux.
correct.
Okay.
That's exactly right. I'm gonna print this out. I wonder if they have some example code. Yeah, I'm gonna bring this up and we will see what I'm talking about. And I'm using Fedora. There are different versions of Linux, but I like Fedora. And I actually like the way the schematics on the X circuit look. Cadence schematics are ugly, man. These guys, it should be criminal. They just put these guys away. Who came up with this ugly stuff? Okay, here's X circuit. Let me show you what I'm talking about. And the stuff that was in our homework that I gave to Dogan, it was from X circuit. Okay, here's X circuit. And you type L, get a component. Let's say we wanted to get a transistor. Let's say you want to get a PN transistor, pick it up, drop it, and then you can draw a wire. See? And it works better with a mouse. It doesn't work very well with. There we go. Close down another component. So we can draw the whole circuit with this.
Okay.
And let me see, can I find some examples of stuff I've done in the past? And you'll see what I'm talking about. In fact, here's something. Let me show you. I just saw a copy of something. This right here is something I did in the past. Okay, this is the simulation result. Okay, all these commands, all this stuff was done with X circuit.
Okay.
Drawing. That was done with Cadence. This is VHDL.
Normally, I use PSpice.
If your simulation duration is not very complex, PSpice is fine. Something really complex, PSpice is gonna be bad. You're gonna have problems.
So for this one, would it be complex or?
For a short window, because your signal's not changing that much, PSpice is fine. But if you had a lot of transitions and stuff, PSpice would be bad.
Yeah, but okay. I just want to get the circuit done today before I leave, just to make sure, because he's gonna ask us.
So you agree to put the low pass filter in it? And remember, a low pass filter.
That's a capacitor and a resistor, right?
Well, the best way to build it is like this. Because if you, and this is C, this is R, and let's say this is VIN, this is V out, and this is a negative terminal, positive terminal. If you look at this, the transfer function for this thing is going to be, and in fact, let's figure out what it is, because I can't remember what this is. I'm going to call this I1, let's call this VX. And so I'm going to have VX minus, and you can put all these calculations in it.
What kind of op amp is that?
Oh, it could be any op amp.
Okay.
Long as its frequency response is broad enough, because you're looking at really low frequencies, you can use a 741.
Okay.
In fact, what you can do is you can use a chip that has multiple 741s inside of one chip, so you don't need a whole bunch of different chips. You know what I'm talking about, right? If you look at, I'm trying to think about part number. There's a part that actually has 4 741s in it. So if you had 4 individual op amps, they're actually all in one package.
Okay.
So instead of needing 4 packages, you just need one package.
Okay.
So this is going to be VIN minus VX over R, and I'm going to call it I1. And then this other one, I'm going to assume it's going the same way. The reason why, because the op amp, we'll assume that the current going through here is 0. So it's going to be VX minus V out all over. I don't know why I did this, because I'm thinking about resistor is SC, and that equals to I2, which is the current going through here. And and I don't know if you remember that, but you remember for this right here, the XC equals to 1 over SC, right?
I don't remember, but
Yeah, it is. So
the S is what?
The S is complex frequency.
Okay.
And the S
Could it be J? Because I'm seeing J.
It could be J.
Oh, okay.
Because what you're doing is when you're assuming that it's a sinusoidal signal, a steady state, then S equals to J omega.
Okay.
Okay, so that's the reason why you see it like this instead of like this.
Okay.
Okay. Now this right here can be used if the signal is not a sinusoidal signal and it's more complex. Then you'll use S. Okay. And so the point is you end up with this because if you take this right here and divide it by 1 over SC, what you're going to do is multiply top and bottom of SC. This will cancel, and then you'll end up with SC on the top.
Okay.
Okay, so that's the reason why it's just SC. Okay, so now I have VIN minus VX over R, and that equals to SC VX minus V out. Okay, and then I can divide both sides by this guy. So I end up with SRC over VIN minus VX. And all that equals to VX minus V out. And then the last step, which I'm sure you look like magic, is we know that V out equals to negative AV times VX.
AV.
Yeah, that AV is the voltage gain of your op amp.
Okay.
This is the op amp.
Okay.
Amp. Voltage gain. I'm sure you guys must have done this in some class.
Yeah, it's been a while for me.
Okay. Well, there's a last trick here. What happens is VX then equals to V out negative over AV. Well, AV is assumed to be approximately infinite. So anything divided by infinity is what?
Infinity.
No.
Or zero.
Zero. Infinity. This is 0. So because it goes to 0, that means this term and this term is going to drop out. So then what I end up with is VIN over SRC equals to negative V out. So then what I can write this V out equals to negative VIN over SR, like that. And if you look at this ends up being a filter with the pole at 0. Yeah, because the pole is where this expression blows up. So H J omega equals to 1 over J omega RC. And so I don't know if I like that, but the pole actually ends up being at 0. Yeah.
So may I scan this one and send you this
Which one is it?
papers that I have?
Which papers?
Um,
Oh yeah. You need to scan that stuff, and we probably also need to talk about what we're going to do about the lakes, the grade versus the lake.
Yeah.
Just take a maximum of 10 points, and
10 points.
if it's several days late, then it's